Physics Part 386. Background radiation. Radioactivity is a natural phenomenon. Rocks such as granite contain small amounts of radioactive nuclide. Some foods we eat emit radiation, and even our bodies are naturally radioactive. Although the atmosphere provides life on Earth, with some shielding, there is nevertheless some radiation from outer space, the cosmic radiation. So, see, radioactivity is always there. The background radiation. Radioactivity is a natural phenomenon. Rocks such as granite contain small amounts of radioactive nuclides. Some foods we eat emit radiation, and even our bodies are naturally radioactive. Although the atmosphere provides life on Earth with some shielding, there is nevertheless some radiation from outer space, the cosmic radiation. In addition to this natural radioactivity, we are exposed to radiation from man made sources. These are found in medicine, in fallout from nuclear explosions, and in leaks from the nuclear power stations. The sum of all this radiation is known the background radiation. Our figure indicates the relative proportions of the background radiation coming from the various sources. Radon and its daughter products are released into air following the decay of naturally occurring uranium isotopes found in granite. Well, we see there is medical sources such as X-rays have got 12% of the radiation. Internal sources from the food we eat, liquids we drink, and from the air we breathe has got 12% of the radiation. We've got cosmic rays from the outer space causing 10% of the radiation. And then we've got gamma rays from the rocks and soil contributing 14% of the radiation. Well, the radon and its daughter products are released into the air following the decay of naturally occurring uranium isotopes found in the granite, and they contribute to 51% of the radiation. These are the sources of the background radiation. In carrying out experiments with radioactive sources, it is important to take account of the background radiation. In order to determine the count rate due to the radioactive source, the background count rate must be subtracted from the total measured count rate. Allowance for background radiation gives the correct count rate. The spontaneous and random nature of radioactive decay. Detection of the count rate of radioactive sources show that the emission of the radiation is both spontaneous and random. It is a spontaneous process because it is not affected by any external factor such as temperature or pressure. Decay is random in that that is not possible to predict which nucleus in a sample will decay next. There is, however, constant probability or chance that nucleus will decay in any fixed period of time. We will look at this in more detail in our upcoming section. Well, we've got a section summary here for three sections, of course, for alpha particles, beta particles, and radiation. And the summary says number one, an alpha particle is a helium nucleus, two protons plus two neutrons. Two, a beta particle is a fast moving electron. Three, radiation consists of short wavelength electromagnetic waves. Nuclear notation, nucleus number, proton number, X, where X is the symbol of the chemical element. Next, in nuclear notation, I beg your pardon, the emissions are represented as alpha particle Pho2 He helium, beta particle 0 minus 1 E charge, radiation 00 or radiation. Next, alpha particle emission reduces the nucleon number of the parent nucleus by 4 and reduces the proton number by 2. Beta particle emission causes no charge to the nucleon number of the parent nucleus and increases the proton number by 1. Radiation emission causes no change to nucleon number or proton number of the parent nucleus. Radioactive decay is a spontaneous random process.